Moving on to properties of logs. So today we're going to talk about some different properties, which hopefully is a reminder to you of things that you've already learned. And we're going to also use the calculator a lot, so make sure that you have that handy. So first thing we're going to talk about is something called the change of base. Base. Anyway, so if we wanted to evaluate a log, let's say, for example, log base 2 of 7. Well, when I look at my calculator currently, I don't see a button here that lets me evaluate that with a base of 2. I don't even remember if I just said 2. I have to have bad of a memory. But my point is that we have a log button for log base 10, the common log. Now, if you do have a newer version of a calculator, there is a way to get a base other than 10. Oops, it's log base right here. But it'll be useful to us to still know the change of base, okay? So even if you do have a newer calculator, it's still something good to know and to practice. So all this says is that if I have log base A of x, I can set that equal to log base B of x over log base B of A. So the difference of these two logs having the same base. I can make that same base be like 7, whatever number I want. Although, in terms of the calculator, it's probably most useful to use the common log or the natural log, just because looking at my calculator, I have those buttons right here. Okay? So it says right here, change the following to common log and natural log. So go ahead, use the change of base, and let's see what you got. You don't actually have to evaluate this. In fact, you can't. Go ahead. So hopefully you guys were able to rewrite both of these logs that have a base that's other than the common log, or 10 I should say, or E. So I can write this as log of x over log of 2/3, or natural log of x over natural log of 2/3, and then same for this example. Next, I'd like you guys to evaluate these using change of base. So for example, for this first one, I would first write it as, if you want to use the common log, log of 175 over log of 20, and then get that approximation, round to 3 decimal places. Do that for all three. If you want to use natural log 2, go ahead and do that. Go ahead, put me on pause. Calculator. The first one I got about 1.724. Second one I got negative 2.237. And then the last one I got negative 2. Moving on. So we have these 3 important properties of logs. The first one is the product property. That says if I have a log of a product, I can rewrite that as a sum of 2 logs with the same base, as you see here. The quotient property. If I have a log of a quotient, that's the same thing as the difference of the 2 logs with the same base. Oops, that was an accident. And last but not least, the power property says, why won't this highlight? Come on. There we go. The power property says that if I have an exponent of a log, that's the same as, let's actually highlight this, multiplying that same exponent by the log itself. Okay? Now, especially the product property and the quotient property, those should kind of remind you of some properties that we have for exponents. Okay, that's not a coincidence. Okay, so just think about that. If we have a product of exponents, right? Think about stuff like that. In terms of the power property, one thing that I just want to mention is that if this exponent is even, when you bring that in front, you do want to put absolute value around the x. Okay, because we know that if I were to square or put to the 4th power, any even power of this variable would make it positive. So that's why I want to use absolute value for the x here, okay, if that were to happen, if it's an even exponent. If it's odd, no worries. Okay, these are like one of my favorite things to do ever. Okay, anyway, what I'd like you guys to do is I'd like you to expand each of these expressions using the properties here. Okay, if you need to break it up into multiple steps, go ahead and do that, but At the very end, you shouldn't have any exponents. You shouldn't have any division or multiplication, okay? So let's have you guys try this on your own. If you get stuck or you're not sure even what I'm talking about, then let's have you take a look at the first example, and then maybe you can try the second one on your own, okay? But expand each expression. Go ahead, put me on pause. Okay, let's check our work. Are you ready for it? I mean, are you really ready for it? Are you ready for it? Hopefully you get that song reference. Okay. So, expand each expression. First, I showed how I can separate the multiplication and the division with subtraction and in addition. And then, I know that the square root of x is x to the 1/2. I brought that exponent in front. Second example here to check. Boop. Same thing here. I have that 1/2. Now, you might be wondering, well, why can't I split these up into two different natural logs? Well, remember, when we split up, for lack of a better term, a log, it's because there's a product or there's either there's a product or there's a quotient. In this case, this is a sum. I can't split up a sum of a log. We don't have that rule. Okay? Let's try these two. So this time we're going to do the reverse. We're actually going to condense instead of expand. So we're doing the opposite. So go ahead, put me on pause. Let's see what you can do. Okay, so I got a final answer here is log of the 5th root of x plus 2 cubed, x minus 5, all over x squared minus 3. I would never expect you guys to multiply all this out, okay? So when we say condense, like you can leave the factors as factors. You don't have to multiply them out. However, here you're like, well, you're a little hypocrite because you multiply them here. Well, I mean, this was simple. I could have left my final answer with having x plus 1, x minus 1. So either way, it wouldn't have mattered. The biggest thing here is make sure that this square is applied to both the numerator and denominator. Same with this 5th root, which, yes, it would still be okay if you had parentheses to the 1/5 power. I just like 5th root better. So now we're going to rewrite the expression in terms of natural log of 4 and natural log of 5. So this is a little challenging in a fun way. So what you guys are going to want to do is figure out how can I write 500, for example, in terms of 4 and or 5. Okay? Play around with it. You guys might not get it in the first try. That's okay. We'll figure it out. So go ahead, put me on pause. Let's see what you can do. And just as a reminder, your final answer will have a natural log of 4 or natural log of 5 in it. All right, go ahead, put me on pause. Let's see what you can do. Hey, you didn't put me on pause. So, I knew that 500 is 4 times 5 cubed, which, since I have a product here, I can split that up as a sum and then bring the power in front. Cool. Here, I could split this up as a difference, natural log of 5 minus natural log of 2, but 2 is the square root of 4, so I get natural log of 5 minus 1/2 natural log of 4. Next type of problem. So it's similar in the fact that we want to, at some point, get log base b of 2, log base b of 3, log base b of 5 for these expressions here, and then be able to substitute in their actual values. Okay, note that these don't come from the calculator because log is b. We don't know what the base is. So why don't you guys go ahead and try this on your own. Again, try to figure out what are values that multiply into 30 or divide into 30, something that I can rewrite 30 as that would involve a 2, 3, and or 5. Okay, so go ahead, put me on pause. Alright, so I knew that 30 was 5 times 2 times 3. I can split that up into 3 sums, substitute in their values, and I got 1.7479. For this next one, I knew that 16 is 2 to the 4th, and 25 is 5 squared. I can split those up as a difference. Don't forget that those exponents come in the front. right? A lot of times people keep those exponents up here and then end up putting this value to the fourth power. You're definitely going to get that wrong, okay? Don't fall in for that trap. You should get an answer of negative 0.2294. All right, last but not least, I'd like you guys to expand and simplify. The key thing here would be trying to simplify whatever you can. If you can't simplify, then leave it as the log of whatever, okay? So go ahead, put me on pause, and we'll check our work. So 243 is 81 times 3, which I can rewrite 81 as 9 squared. I can rewrite 3 as the square root of 9. If I bring those exponents in front, I know that the log base sign of 9 is 1, so I get 2 plus a half, which is 5 halves. Here I split this up as this product as a sum, but I know that if I have the natural log of e, that's just 1, so I get natural log of 8 plus 3. Nothing else to simplify there. I could put this in my calculator, but then I'm going to have to round that value, so I want to keep it exact. So I'm going to leave natural log of 8 in my calculator, or sorry, in my answer. If it did say to round to 3 decimal places, then sure, I'll plug it in. Last one here, that's a 5, by the way. I split this up as a difference. I know natural log of e is 1, so I get 5 minus natural log of 7. All right, so just keep in mind our properties. We have the change of base, product property, quotient property, and power property.